Hello everyone. Today we are going to solve the LeetCode problem 396 and today is May 1st and we are going to solve this is the problem of the day and let's read through the question. You are given an integer array nums of length n assuming array ak to be the array obtained by rotating the nums array by k positions clockwise. We define the rotation function f on the nums as follows. So they are defining a function f of k, which is nothing but after rotating the array arr by k times in the clockwise manner, they are multiplying the first element in that array by 0 and then first element by 1 and similarly they are multiplying the n minus 1th element by n minus 1 and this is what is fk is, and we need to return the maximum value of f0 f1 and so on up to fn. So let's see an example which they have given. Here they have declared nums as 4, 3, 2 and 6 and the maximum value they got is 26. Let's see how they have computed f0. F0 is 0 times 4. Like for they haven't rotated any time, so we'll have the same array as it is. Then so the array will be 4, 3, 2, 6. So first element into times 0, second element times 1, the third element times 2, fourth element times 3. So we'll get the value as 25 and then they have rotated it by one time. So the effectively now the value is going to be 6, 4, 3, 2. And if we try to look at it here, we'll multiply this by 0 and this by 1 and this by 2 and this by 3. And they have done the same thing and they have got the value as 16. So again, they have done F2 and F3 as well. And for F3, they have got the maximum value 26 and they are returning the same value. So what here we can clearly see the pattern over here is we are incrementing each and every, like if we are going from F0 to F1, which is one time rotated, we are ultimately increasing the count of F4, like the first element in this by 4, like one time. And then the 3 is multiplying previously as one time, but now we are multiplying it by 2. And then 2 previously it was multiplying by 2 and now it is multiplying by 3. So effectively we have increased all the elements by 1. So first we are supposed to have the total sum of this array, which will then we need to add it to the previously obtained value. Here we have got the total sum to be 4 plus 3 plus 2 plus 6, which is nothing but 7, 9 and 6. It is 15. So 15 is the value and 15 we are supposed to add to 25, which will become 40, and then we are supposed to subtract the now all the values for 6. So clearly note that we have added 6 3 times, and but when we are adding the total summation we'll again have one more value. So we have 4 times the last element and we need to subtract it from the total which we have got 40. So 40 minus 4 into 6, which is 24, and you will get 40 minus 24, which is 16. So we have got 16. Similarly, if we want to go to the next step, we are supposed to again add to 16, we are supposed to add 15, which is the total sum. So which will become 16 plus 15, which is 31. And then from 31, we are going to subtract the 2 4 times. 2 times 4, which is 8. 8 should be subtracted from 31. 31 minus 8, which is nothing but 23. And here we have got 23. And subsequently, we'll get all the values in constant time. So clearly, first we are supposed to have a sum variable, sum equals to 0. And in the first loop, we will, for I equals to 0 to n minus 1, we will accumulate plus equals to arr of I, and we will initially have a variable called f which will initialize to 0, and we will get that particular value I times arr times I to get f0. This is we are constructing This is going to give us f0. And now we'll have a variable called max, which is taking this value, and then we will update the value of f for each and every value. So we'll have another for loop for I equals to 1 to n minus 1. What we'll do is we will directly have the f updated by f equals to f plus sum, but we are supposed to subtract the last element, ARR of n minus I. Here I is the last element, and as we go forward, every time we are going to remove the first we have removed 6, and then we are supposed to remove 2 4 times, then we are supposed to remove 3, then we are supposed to remove 4. So that's why we are using ARR of n minus 1, n minus I. So, and then we will have the max updated equals to max of f and max, which we already have, and then we will return this, return max. I hope it is clear. Sorry, the value is mx. So this is how we are going to solve it. Let's go to the code. So first I have told you that we are going to have 1 second, I think. Yep. So first we have the size of nums, and then we have int sum equals to 0, int f equals to 0, then for int I equals to 0, I less than n, I plus plus, we will have the sum plus equals to ARR, sorry, nums of I, and then we'll have f equals to I times of nums of I. Then we will have the variable called int mx, which will contain this f0 initial value. Then we will loop through all the other. We will calculate the f1, f2, f3 and take the maximum of it. For that, we will go from I equals to 1 to I less than n, I plus plus, and to calculate the updated f is nothing but we will take the previous f from the value and then add the sum to it, and we are supposed to subtract n times the nums of the n minus ith value. So this will give us the answer, and we are supposed to get the max of it. So max will be maximum of mx and then f, which we have obtained, and we are going to return this. Return mx. Let's see if it works. Submit. And of course it does. Thank you.